Welcome to This Explainer. Today, we're unpacking the ultimate strategic playbook for planning, launching, and scaling a business in the modern commercial space industry. We're going to look at everything from the hard economics of manufacturing and business strategy all the way to the cutting-edge physics that will literally propel us to the stars. So, whether you're an aspiring founder, an investor, or just someone fascinated by aerospace, this is your blueprint for the future. Let's get into it. Here is our roadmap for today. We'll be covering 6 key areas: the new space economy, launching your space startup, mastering vertical integration, the SpaceX success blueprint, the essential aerospace workforce, and finally, the ultimate interstellar horizon. Section 1. The new space economy, from a government monopoly to a private boom. We've moved so far away from the rigid, sluggish oligopolies of the past into a wildly dynamic new era. Think about it. Legacy aerospace giants used to hold up to 80% of the sector. They relied heavily on standard, cost-plus government contracts. And because those contracts basically guaranteed a profit percentage on top of whatever the expenses were, well, there was absolutely zero incentive to save money or move quickly. Today, it's a completely different ballgame. A new breed of entrepreneurs, armed with agile methodologies and backed by return-hungry investors, are actively shifting the market. They're laser-focused on radical cost efficiency, rapid iteration, and shedding all that unnecessary corporate baggage to completely rewrite the economics of space access. Section 2. Launching your space startup, the entrepreneurial spark. So, today's space startups aren't just building rockets anymore. They actually operate across a really diverse range of highly profitable domains. You've got Earth observation analytics, helping manage global climate risk, orbital infrastructure designed for complex in-orbit servicing and logistics, right down to downstream data software that turns raw satellite feeds into actionable intelligence. The secret sauce here is that these companies are constantly connecting space capabilities to real economic activity right here on Earth. They're making the space industry a fundamental layer of the global economy. If you're a founder looking to build in this space, you absolutely need a scalable, well-defined business model. There are 5 proven steps to get there. 1. Conduct rigorous competitor analysis. 2. Define a rock-solid core technology. 3. Clarify exactly what tangible value you bring to the end customer. 4. Tie your funding strategy strictly to verifiable milestones. And 5. Identify a winning niche. In an industry that is this inherently expensive and complex, finding your unique differentiator is absolutely essential for long-term survival. Section 3. Mastering vertical integration, the secrets to scaling up. For modern space startups, achieving true economies of scale isn't just a nice-to-have. It is absolutely necessary, especially when you're talking about planning and building massive satellite constellations. Vertical integration means bringing previously outsourced elements of the supply chain directly in-house. By ditching the old reliance on a tangled, slow-moving web of third-party suppliers, companies can drastically increase their operational efficiency and really lock down their costs. Now, founders do have to weigh this strategy very carefully because the stakes are incredibly high. The pros are massive. You get to absorb all the surplus value from learning effects as your teams build and iterate in real time. But the cons? They're intense. Vertical integration is a near irreversible corporate strategy. It demands incredibly high initial setup costs and significantly increases your internal technical risk, simply because you are now responsible for every single nut, bolt, and circuit board. But the math behind this decision is absolutely fascinating. According to current engineering data, for a smaller 3U CubeSat constellation, a vertically integrated approach actually breaks even with traditional outsourcing methods at just 88 satellites. Given that average commercial constellations today aim for about 150 satellites, operator manufacturers are literally leaving money on the table if they ignore this strategy. At a certain scale, building it yourself just mathematically makes sense. And it gets better. If you're building larger 300-kilogram satellites, that break-even point plummets to just 39 satellites. This proves that despite those intimidating capital constraints up front, vertical integration rapidly pays for itself. It empowers agile companies to aggressively accelerate their development timelines, iterate without waiting on sluggish suppliers, and ultimately dominate their specific niche in the new space economy. Section 4. The SpaceX Success Blueprint, validating the model. To see this exact manufacturing and business blueprint executed at maximum scale, we just have to look at our ultimate case study, SpaceX. They entered a heavily entrenched, government-dominated industry and fundamentally rewrote the rules with one singular, unyielding focus. And this wasn't just some clever marketing spin to appease venture capitalists, right? It was a pure, relentless engineering mandate to make space travel drastically cheaper, highly reliable, and accessible for long-term human exploration. They planned their entire business around the physics, not the other way around. They achieved this grand vision by solving the industry's absolute biggest bottleneck, the disposable rocket problem. Instead of chucking multi-million-dollar hardware into the ocean after a single use, the Falcon 9's first stage separates, literally flips around in a vacuum, fires its engines, and autonomously returns to Earth to fly again. This specific technological breakthrough is the exact paradigm shift that unlocked the modern commercial space age we're building today. And because they own these reusable rockets, SpaceX dramatically lowered their own internal launch costs to deploy Starlink. This communications network is planned to boast over 10,000 satellites by 2026, serving millions in remote and underserved regions globally. It is the ultimate proof of concept for vertical integration. By controlling both the launch vehicle and the payload, they now operate more active satellites than the rest of the world combined. Section 5. The Essential Aerospace Workforce. Bringing vision to reality. But here's the thing. To actually build thousands of satellites and fully reusable next-generation rockets like Starship, you need way more than just great ideas. You need an elite workforce. In this industry, white-collar engineering must seamlessly meet blue-collar machining. The real unsung heroes behind these technological marvels are the highly skilled technicians and machinists working out on the factory floor. Deploying elite talent from specialized providers like FlexTrades isn't just helpful, it's absolutely critical to bringing these ambitious multi-million-dollar missions off the drafting board and safely onto the launch pad. Section 6. The Ultimate Interstellar Horizon. Planning for the Stars. With our business logic, our manufacturing supply chains, and our workforce fully mapped out, let's turn our attention to the long-term physics driving the future of the industry. This brings up a truly mind-bending question. As commercial companies lay the very real groundwork for lunar bases and Mars colonies over the next few decades, how do we eventually plan for interstellar travel? The physics required to leave our solar system challenge everything we currently know about propulsion, energy, and even corporate timelines. To understand the constraints of deep space travel, we first have to grapple with time dilation. This phenomenon was actively tested when astronaut Scott Kelly orbited the Earth at a staggering 17,000 miles per hour for nearly a year, while his identical twin brother, Mark, stayed right here on the ground. Because his rapid speed converted his movement through space into movement through time, Scott Kelly became an actual, literal time traveler, aging just a fraction of a second slower than his brother. This proved that time dilation isn't just an abstract theoretical concept you read about in textbooks. It is a fundamental engineering constraint that future space businesses will have to actively plan for when they're coordinating missions across vast astronomical distances. But even traveling near the speed of light takes years just to reach neighboring stars. So to reach a star like Proxima Centauri in days rather than millennia, future space startups might attempt to build an Alcubierre warp drive. This theoretical engine would carry a ship subluminally, meaning slower than light, within a superluminal or faster-than-light warp bubble. You'd effectively be riding a wave of contracting and expanding space across the cosmos. Now, the math to build this requires exotic matter and negative energy. And while this currently violates classical physics, quantum physicists believe the negative mass required for these space warps and traversable wormholes might actually be possible through experimentally verified quantum phenomena. Things like the Casimir effect, where empty space actually pushes objects together. I know it sounds like pure science fiction, but the theoretical foundations for tomorrow's interstellar startups are literally being laid in labs today. The space race, once rigidly defined by geopolitical rivalry, now thrives on private innovation and incredible shared ambition. As the commercial space industry evolves from basic Earth orbit logistics to a booming interplanetary infrastructure, it leaves us with one final thrilling question. What incredible, world-bending realities will the next generation of space entrepreneurs engineer? Keep looking up, keep building, and thanks for joining me for this explainer.